We are given a few examples of carbocations. We have to give the order of stability of the cations. We are giving the order of decreasing stability in the series. We start with the most stable cation and end with the least stable cation. Tertiary butyl is the most stable and methyl is the least stable of the cations. In CH3+, we have only 3 hydrogen atoms around carbon. In ethyl, we have a methyl group donating electrons by +I effect. Any group which donates electrons is supposed to have a +I effect, inductive effect, donating electrons. When this happens, the charge density on the cation slightly decreases. So, an alkyl group has the effect of stabilizing a cation. When the number of methyl groups increases, there are more groups donating electrons by +I effect, and therefore the distribution of charge increases. This results in the overall reduction of charge density on carbon, and therefore the stability increases as there are more alkyl groups. Thus, tertiary butyl cation is the most stable because it has the most number of alkyl groups. The general order of stability is a tertiary cation is more stable than secondary, which in turn is more stable than a primary, because in a tertiary cation we have 3 alkyl groups attached to the charge bearing carbon. In a secondary we have 2 alkyl groups, and in a primary there is only 1 alkyl group attached to the charge bearing carbon. As the number of alkyl groups increases, there is greater distribution and greater stability. The least stable is the methyl cation. In general, electron donating groups stabilize cations because any charge concentration is destabilizing and any charge dispersal, which results in the lowering of charge density, would stabilize the species. We have used a phrase inductive effect. This is causing polarization of a bond due to difference in electronegativity. When a group or atom is more electronegative, it draws electrons away. Similarly, bond polarity may also cause a polarity on an adjacent bond. This effect is called the inductive effect. This basically operates among sigma bonds only. A group that is more electronegative draws electrons away and tends to become negative. This group is said to exhibit a -I effect. A group that donates electrons tends to become positive, and therefore it is said to exhibit a +I effect. There is another effect called the mesomeric effect, given the symbol -M or +M, which will be seen later. But this can operate only through pi bonded systems.